welcome to another one of the Clean Code Book walkthrough series videos. In this video, we will go through chapter 2 of the book, which is called Meaningful Names. And this is one of my favorite chapters because I think naming is really key to making your code readable and maintainable by others. So yeah, with that, let's get right into it. So the first thing that Uncle Bob covers in this chapter is that we should use intention revealing names. So, the name should tell you why it exists, what it does, and how it's used. So, if you consider a name like int d, and then you have to put a comment saying this is the elapsed time in days, the name itself doesn't reveal the intention, right? So, if you name it something like elapsed time in days, or days since creation, or days since modification, or file age in days, these names reveal what is being measured and then also why it's used, right? So this the naming here makes a huge difference when you read the code, when the name reveals the intent of the variable. So, an example is if you look at this code here, it says get them. There's a list 1, and it's looping through the list. Each list has an integer array, and if it's checking if the first element of the array is 4, then it adds it to this list and returns that list. So this code is simple, right? It's just a for loop with an if statement, a filter, and then it returns a resulting list. But then it does not explain itself, right? Like, what is list 1? What is the list? What is 0 here represent, right? What is 4 is like, why am I checking that if the first index is 4, what does this mean, right? And what is x? Like, what does x represent? So this code, while it's easy to understand, it's what it's doing in terms of like the programming language. It's filtering the list and finding everything whose first element is 4 and adding it to a resulting list, but we don't understand like why this is doing this and what these things represent, and it's hard to read this code in that sense. And so these are two versions of the code that are that improve it. So if you look at the first version, now we say, okay, it says get flagged cells, so you're probably dealing with a grid, and then you have some sort of you're trying to figure out which cells are flagged. And so here you can say, oh, okay, there's for each cell in the game board must be some state variable. We say if the status value of the cell is flagged, then we add it to the flagged cells and we return the flagged cell. So this tells me a little bit more that, okay, this is looking at a game board and looking at all the flagged cells that are flagged and returning it. And this makes much more sense to me when I read this code. And if you consider another version of the code, which I think is just a slight improvement, where we take this int array and wrap it in a cell class, and then it's like even more clear. You loop through all the cells on the game board. If the cell is flagged, add it to the flagged cells, and then return the flagged cells. So in terms of simplicity, this is exactly the same as the code that we saw before, but this is much more cleaner in the sense that by using good naming, we reveal the intent of the code just by using good naming. Yeah, the second part of this chapter is avoiding disinformation. So avoid false clues that could obscure the meaning of the code, right? So for example, HP, AIX, and SCO would be poor names because they are Unix platform or variants. So like, if you name something, let's say it's a hypotenuse as HP, this could give a false clue or false information that it's something to do with the Unix platform. So avoid doing something like that. Try to be wary of making sure that your names are not misleading or ambiguous. And another example of this is, let's say you have a group of accountants, and if you name it account list, and it's not actually a list. Let's say it's a set of accountants or just a collection of accountants, then don't name it account list, because that could give the false information that it's the specific list data structure that we're dealing with, right? List means something very specific. So it's not the case that all groups of accountants will be represented as lists. They could be sets, they could be collections. And so don't name avoid doing this where you could give out false information about this variable. So, maybe better names would be account group or bunch of accountants, or basically just accounts, right? These names do not they still tell you what it is without giving potential false information about the variable. So next is make meaningful distinctions, right? So if you're making a distinction, make sure the distinctions are meaningful. So let's say, just because you need to name two variables A and you can't do that, don't name them A1 and A2, right? Like, make 1 and 2 don't tell me about how A1 and A2 are different, right? Maybe these are two file names, and you can probably, if it's a copy function that takes two arguments, instead of naming it A1, A2, maybe you can say source and destination, right? So using source and destination makes a distinction between these two variables that tell me the meaning, right? So it's a meaningful distinction. And don't, like, product info and product data, right? Like, these info and data basically mean the same thing. So don't use these types of words to differentiate these two classes, because the name doesn't tell me what's actually the difference between how product info is supposed to be used versus how product data is supposed to be used, right? So instead, either just have one class, or if you're splitting the class for some other reason, make sure that reason is apparent in the name. So if if you have one that's like your API product and one that's your database product, then maybe you can name one of them as product DB record, right? And the other one is just product, which is your API level record. So that tells me that, okay, this one represents how the product is represented in the database, versus the other one is how the product is represented in the API. So now, a similar example is, don't use like prefixes like a num or the num because num is already taken, right? So again, make meaningful distinctions between what these numbers represent. And these are some examples from a real application. So it's like get active account, get active accounts, get active account info. Like, how do I know which one to call, which one to use, right? If I see these methods in a class or an interface, I like, what the hell is the difference between these two? Like, the distinctions, the name doesn't make it clear how these are supposed to be used differently. And so, the next thing is use pronounceable names, right? So usually when coding and programming and software engineering is a collaborative activity. People discuss it. So, make sure the names are actually pronounceable, right? Like, for example, this name, Gen Y MDHMS, is a name that, Uncle Bob mentions, where people would just go around saying Gen Y MDHMS, and, if you try to read the code, you're going to be like, Genimdimus something, it's very hard to use this in vocabulary and reference it. So, just make sure you're using names that are pronounceable. Next, use searchable names. Now, searching is something that programmers always do, right? Like, if you want to find everywhere in the code where this is used or everywhere this is referenced, you would typically take the name and search for it across the code base. Now, the ideal experience is that you don't get any extra results and you get all the results of the thing that you're looking for, right? So if you have something called max classes per student, if you search for this, it'll give you pretty close to what you're looking for in terms of it won't give you any extra results that you don't need to care about. It will actually give you everywhere that this is used. But if you name something like E or A or R and then try to search for that across the code base, it's, E is like the most common letter in the English language. So there will be a lot of strings and parts of your code that that have this, right? So these names are not very searchable in that sense. So make your names meaningful, in this, and at the same time they will be searchable, right? If your names are well spelled out and reveal intent, they'll automatically be searchable. So this is another reason why good naming matters, because sometimes you just want to search and find all the usages of a variable. So next is prefixes or distractions, right? So a lot of languages have best practices, like C++ says you put an M in front of every member variable, like M name, M description, or use an I in front of an interface saying I shape factory. So these prefixes are distractions, right? Like if in C++, if your classes are small enough and do one thing, then you wouldn't need to make it use these prefixes, right? So you can just keep it name, description, and it'll be, if your code is small, single responsibility, it'll be obvious that these are member variables. Like that doesn't need to be made apparent in the code, because it just invites you to create bloat in the class. And similarly, shape factory and I shape factory, like when people use my interface, I don't need them to know that it's an interface or there's implementations behind it. They don't need to care to use I shape factory. Like all I need them to know is you're using a shape factory. Now whether that's an interface, implementation, how it's given to you, it's none of your business, right? So these prefixes, according to Uncle Bob, are distractions. And I also agree, not using I in front of an interface is something I like to do. I'd rather suffix the implementation saying shape factory impl or XYZ shape factory, right? Because that's, the users of the class don't care about that. That's just how I choose to implement this interface. But when my clients or people who are using my API are using this, they just need to know that it's a shape factory. They don't care what's underneath. So yeah, the other tip on naming is, class names are usually nouns, not verbs. So account, it's a noun, or date, person record retriever, right? So class that retrieves person records. And yeah, avoid meaningless general words like manager, processor, data, or info, because these don't really actually tell you anything. You can be doing a lot of things and call it manager. It would sound sensible, right? You could be doing a lot of things and call it processor because it's a process of doing something. So it's not specific or intention revealing in terms of what actually it is doing, right? So if you have something like, product data retriever, then it's very clear that, this class retrieves product data. But if you name it like product data manager, you could be doing all sorts of things with the product data there. You could be reading, writing, manipulating, updating. It's invitation to bloat. So the manager word doesn't tell me anything about the intent of the class. And similarly, method names are verbs. So a class is a noun and a method name is a verb. So if I have a class called, let's say, product data retriever, I would probably have a method there that says retrieve, right? So, or retrieve product, right? So it's a product data retriever, and what it can do is it can retrieve a product. So, and here are different other names like post payment, delete page, save. These are all verbs. So don't name a method that isn't a verb, right? Don't say product data retriever dot product data retriever, right? That's the method name should be an action or a verb. And then reduce cognitive load, right? So don't try to name things which readers have to know something about and then map it to something else. Just be very clear as possible as to what it is and direct, right? Don't expect your readers to know about some inside jokes or something to map the name to something else. And avoid like names like holy hand grenade for things that mean maybe delete items, right? So yeah, avoid these names where the reader needs to kind of map and figure out or know something to know what's going on. Just clarity is king in this case. Just be very clear and about what the intention is. Yeah, and the other thing, I really like this part of the book which says, use one word per concept across a code base, right? So let's say you have a class which has like a product data retriever, a person data retriever, and let's say a class data retriever, right? Like the class is in a school. And so if each of those methods are in the same code base, in the same, database layer, and in one you call it fetch, you call the method fetch, in another one you call it retrieve, and in the third one you call it get. These are different names, and if I come and read this code base, I was like, why has he used different names to do the same thing, or are they actually doing something different? So it might mislead the readers to think that there's some differences, which is why a different name was chosen. So if it's actually representing the same semantics, which is go to the database and get a record, then just use the same word. So it's either going to be fetch, it's going to be retrieve, or it's going to be get. Just pick one and stick with it. And the flip side of that is don't pun, right? So if something is actually having different semantics, don't use the same name in the name of consistency, because then we mislead the reader to understand that there's a difference in semantics, right? So for example, if I have a method that has, or if I have a class that has a method add, which basically what it does is it takes two values and sums them or concatenates them, then I call that add. But then if I now have a new class where it's managing a list or a collection, and then I put a method there, add, which actually appends the item to a list, that could be misleading, right? Because those are different semantics. I'm not concatenating or merging two lists. What I'm doing is appending an item into an existing list. And so maybe something like append or insert would be a better name here, because the semantics are different, right? You're not adding in the same way as summing two numbers or concatenating two numbers. So if you've used add to represent that in your code base, don't use add to represent appending something to an existing item, right? So that would be a pun. And so use different words to represent those, because those are different concepts, right? So the takeaway here is use one word per concept, and do not use the same word to represent multiple concepts, and do not have the same concept be represented by multiple words. So it's strictly one-to-one. Yeah, and then shorter names are generally better than longer ones as long as they're clear. So in general we like short names, but then we still prefer clarity over length, right? So try to come up with the shortest words that's clear enough. I think that's the kind of tenet that we go for. And do not add more context to a name than is necessary. So just don't, again, this goes back to avoiding misinformation and false information. So yeah, just wrapping up this chapter then, the hardest thing about choosing good names is that it requires a skill to describe things and a shared cultural background, right? So sometimes things could mean different things in different cultures as well. So that's why naming is hard, right? So it is something we do to make everyone understand. The computer doesn't care if you name something a game board versus grid, right? The computer will process it the same way, but this naming is a problem that is for everyone to understand, the code we're writing. And so you'll probably end up surprising someone when you rename, right? Like sometimes you think that it's a non-trivial improvement, but if you just make all these small naming improvements, you'll be surprised at how it'll increase the level of understanding people have about the code. And also, since now when you make changes, you can easily avoid bugs that stem from not understanding the implications or the risks, right? So it's much easier for people to reason about in terms they already know versus having to map it to something else or to a different names and then reason in that the problem space, right? So the code we saw earlier about Minesweeper, if you have this grid and X and 0 and 4, if you ask someone to make a change there, he might easily screw it up because it's very hard to reason about that. But if you see the improved code where it's like, where you have a cell, you have a game board, and you're doing is cell dot is flagged, as you make changes to that code and you try to read out your updated code, it's going to be easy to find mistakes and bugs. Follow some of these rules that we discussed, and if you're working on an existing code base, there are a lot of refactoring tools and IDEs that allow you to do renaming and such, and so make use of those, and it'll pay off in the short term and continue to pay in the long term, because it'll just increase everyone's understanding and make it easy to maintain your code base. So with that, I'm wrapping up, and thank you for listening to this video. If you liked the video, subscribe to my channel, and I'll be posting videos for the remaining chapters in the coming week. Thank you.